3년. 3년을 하고, 또, 1년이 하고, 그걸 안 보내줬구나. 뭐야, 혹시 지금 보내줬더니 양말? 누가 있어요? 지금 저한테 줬던 이메일로 주고 받았잖아요. 이메일 백처를 PDF 파일을 보내줄게요. 지금 다운로드 받아서 볼 수 있는 사람 보고 보면 될 것 같아요. 지금 꼭 보내줄게요. 준비하고 갈까요? 좀 팩스. 팩스. 진. 반갑습니다. 아직 다 안 온 것 같은데 좀만 기다리고 시작할게요. You're going to keep all of this space. Part 3. 자, 지금 들어온 학생들 3열 이상을 앉으십시오. 3열. 보세요. 학생들 오늘 기다리는 거 자기소개 한번 짧게 해봅시다. 기다리는 동안 저는 조금 이따 갖고 학생들부터 자 여기부터 약간 누구의 들어왔어요? 이렇게 해주세요. 저 내과 1학년 이상철이라고 합니다. 이상철. 끝까지 칠 건 없고. 왜 이상철 학생 왜 코딩에 듣고 싶었어요? 저 약간 예전부터 잘은 모르는데 배워보고 싶었어요. 잘은 모르는데 배우고 싶었어요? 또 여기
저 예과 2학년 유성훈이라고 합니다.
유성훈 학생 네, 왔어요. 유성훈 학생은 동기가 뭡니까?
원래 그 정보보안 관심이 있었는데
정보보안.
네. 저희들 와가지고 이제 좀 접할 기회가 없었는데
네.
지금 코딩 가 생겨가지고
네.
다시 참가하게 됐어요.
원래 정보보안 쪽 하려면 컴퓨터공학이나 전기전자 이런 거 해야 되는 거 아닌가? 그죠? 3년이요. 아깝게 아니죠. 네. 그러면 다른 학교 혹시 입학했다가 이렇게 다시 온 거예요?
여러 개를 붙였는데 그중에 두 개를
의대를 했어요? 그리고 그런 쪽으로도 있었어요?
고려대 사이버방
아이고. 와. 여기 좀 뒤에 학생. 여기를. 잘 보세요.
이과 2학년
정문영 학생. 정문영 학생은 선생님들 그런 동기가 뭐예요?
저는 조금 가벼운 마음으로 할 거거든요.
할 수도 없고 지금 있으면 심심하니까 헌기다며 볼까요?
그거랑 별개로 부담물이
보험을 줬어요?
네, 교수님 말씀하신 거 듣고 내가 해봐야겠다 생각하고.
그래요? 오케이.
그러니까 저는 예과 2학년 박지호입니다.
박주원 학생. 네.
저는 이제 공학생이 아무래도 코딩을 공부하려고 생각하고 있어서 지금 좋은 기회.
진짜? 무슨 코딩 공부하려고 했어요? C. 특별히 C를 공부하고 싶은 이유가 있었어요?
그냥 내년도에 좋은 학원이 있어서
진짜? 여기는 저과 이양 주성용 학생의 여기는 학생을 왜 들고 싶어요?
예전에 한번 하는 걸로.
응. 진짜 한번 해본 적 있어요? 무슨 그림 그렸어요? 시험으로? 시험을 많이 보면 C. They're interested in what they have found C. 어디 다른 학교 때 가서 혹시 C 배운 거 아니면 혼자서 이제 C를 고등학교 때 C 언어가 사실 되게 어려운 코딩 중에서는 어려운 랭귀지 중에 하나거든요. 그래서 저도 C는 잘 못해요. 파이썬은 잘 못해요.
제가 예과 1학년 정희구라고 합니다.
동일대 학생.
제가 수업 듣기 같은 거는 첫 번째는 코딩을 배워보고 싶어가지고 이번에 인문학에 코딩을 배우라고 생각해서 배워보게 됐습니다.
이번 기회를 통해서 컴퓨터랑 친구가 되기로 그렇게 정의석 교수님, 정의석 교수님하고 여기
그 예과 2학년 김재현 나중에 이제 또 다른 경쟁력이 될 수 있을 것 같아요.
혹시 그 방학 때 그 저기 종명 중간 조은대 학생처럼 조은대 학생처럼 그 연구실 그 하고 있는 사람은 그 다른 교수님하고 얘기해 혹시 지나간 사람 중에 혹시 연구실 참여하고 있는 학생 누구 교수님하고 국현 교수님 조은대 학생 예전에 뭐 해봤어요? 진짜? 어떤 거?
예과 2학년
김정민? 또?
연구실 활동하다가 교수님 병원에 가서
그래? 너무 좋습니다.
저는
똑같이? 너희들이 같이? 홍보했다 정의석 교수님? 홍보했다 정의석 교수님? 또 여기
예과 1학년 김서진.
문제들 할때
저도 고등학교 때 파이썬가 나왔어가지고 같이 무슨
고등학교 때 교과과정으로 배웠어요? 아니면 어떻게 배웠어요?
교과 과정
교과과정으로?
마음에 들게 했었어요.
고등학교 때 과목이 있어요? 진짜? 무슨 뭐 특목 같은 거 있어요? 이런 데도 그런 게 있었어요? 알겠어요. 지금
그 예과 1학년 문학이니까
민학생
저도 연구실에서 연구할 때 도움이 될 것 같아서 지원했어요.
무슨 나왔어요?
도움하는
대박이니? 오케이. 학생들은 늦게 온 그거야. 여기 지금 들어온 학생들 여기 앉으시고 들어오세요. 자, 여기 하나 앉아요. 다 왔다. 한 명이니까. 오케이. 자, 자기소개해 주세요. 이현경 선생님. 오케이. 큰 교수님. 여기 학생들 박현 교수님만 해서 학생들 처음 봐요. 매일 봐요? 매일 봐요? 오케이. 박사가죠? 의과학과? 예.
저 문학과 교수님 정한
정환 선생님. 오케이. 박사가죠?
네.
자주 봐요?
네.
임용 동일하게 국회의원 교수님 국회의원 교수님이 혹시 별 관심 없는데 그냥 가라고 시켜서 오지는 않아요? 네. 열어주십시오. 자기소개. 대학원생인데 연구원들 오늘 교수님과 조영 교수님 알겠습니다. 연구원이시죠? 예, 많이 오셨네요. 예, 지금 시간이 다 도착하겠습니다. 그래서 저는 그 영상의학과교수 박일우입니다. 그래서 학생들 중에 의학을 듣는 학생들이 별로 안 되는 것 같아요. 그래서 그때 저도 본 학생도 있었는데 아무튼 지금 왜 모였는지는 다 알고 여름방학 8주 동안 여러분들한테 파이썬을 가르치는 기회를 주고 싶어서 제가 이렇게 이메일로 카톡방에 공지가 올라왔는데 광고 보고 연락하고 잘 왔습니다. 그리고 제가 이런 여름방학 때 학생들 대상으로 코딩을 가르치는 거를 거의 한 3년째인가요? 하고 있어요. 그래서 외학물 시간에 제가 수업 시간에도 이렇게 얘기하는데 의료인공진, 인공지능 여러분들이 너무 다 잘 알고 있지 않나요? 그래서 제가 이 예과 학생들한테 여러분 의사과대 학생들이잖아요. 의사과대 학생들한테 코딩을 좀 가르쳐주고 싶고 코딩을 배워야면 좋겠다고 생각하는 이유는 오늘 여러분들이 어떤 형태로 의료병에서 어떤 형태의 의사가 될지, 학교를 하는지, 공부를 하는 의사가 될지, 기업의가 될지, 아니면 그것도 아닌 공공수에 될지 모르는 모르지만 어떤 형태의 의사가 되든 특히 연구를 하는 위치에 있게 된다면 코딩을 배우는 것이, 파이썬을 배우는 것이 꼭 인공지능뿐만이 아니고 지금 얘기하는 의료인공지능이 여러분들이 의사가 됐을 때 10년, 15년 후에 어떠한 형태로 바뀌게 될지 그리고 어떠한 형태로 진화가 바뀌게 될지 모르지만 연구를 하는 데 있어서 코딩을 배우는 것이 굉장히 큰 무기가 될 겁니다. 큰 도구가 될 겁니다. 툴이 될 겁니다. 그래서 그런 기회를 주기 위해서 이런 여름방학 때 이런 캠프를 마련하고 물론 8주 동안 많이 배우면 많이 배우고 적게 배우면 적게 배울 것 같아요. 근데 제가 목표하는 거는 코딩은 컴퓨터 프로그래밍 랭귀지라고 하잖아요. 그렇죠? 그래서 대부분의 학생들이 조금 경험한 친구들이 있지만 한 번도 코딩을 해본 적이 없는, 파이썬을 해본 적이 없는 학생들도 있을 텐데 괜찮습니다. ABC부터 배우고 우리가 언어를 배우는 것처럼 ABC를 배우고 문법을 배우고 단어를 배우고 단어들의 조합을 배우고 단어들의 조합을 이렇게 어떻게 문장을 만드는지 이런 거를 배우는 것처럼 그런 기본적인 과정을 배울 겁니다. 8주 동안. 그리고 여러분들이 만약에 더 관심이 있다면 조금 더 그게 문제응용이 될 수도 있고 코딩을 이용해서 연구에 적용하는 것이 될 수도 있을 것 같은데 그럴 수 있는 혼자서 그런 거를 이용할 수 있는 좀 더 찾아보고 좀 더 스스로 공부하고 스스로 공부할 수 있는 그런 틀을 파운데이션을 주기 위한 그런 코스라고 생각하면 될 것 같아요. 그래서 8주 해가지고 여러분들 인공지능 전문가가 당연히 안 될 것 같고 안 되죠. 프로그래머가 될 수가 없습니다. 그러나 그렇게 발전할 수 있는 기반을 만들어주고 싶어서 그리고 충분히 가능하다고 생각합니다. 이런 클래스를 드리겠습니다. 제가 3년째 이 클래스 이런 여름방학 때 이런 캠프를 진행하고 있다고 했는데 그래서 작년에 혹은 재작년에 이 캠프를 같이 들은 학생들이 지금 TA로 이번에는 TA로 참여했고요. 그래서 우리 TA를 제가 한 명은 안 왔어요. 근데 TA를 한 명씩 소개해 줄게요. 양가의 학생은 본과 1학년이에요 지금. 그리고 재작년부터인가요? 작년부터 클래스를 참여하고 저희 연구실에서 같이 연구를 실제로 진행하고 있습니다. 문진 연구를 진행하고 있고요. 그 옆에 양서연 학생은 총이구나. 처음인데 저희 연구실에서 그 예과 연구생들이랑 같이 일하는 게 아니고 연구에 참여하고 있고 그래서 조금 더 일찍 시작했어요. 이 코딩 배우는 거를 한 2달 정도 전에 시작한 것 같아요. 그래서 수업을 같이 들으면서 또 TA로 같이 할 거고 그 옆에 윤덕후 학생입니다. 윤덕후 학생은 예과 2학년 우리 친구들이 아는 친구 있죠? 윤덕후 학생도 작년 여름방학 때 보otcamp 참여하고 역시 그거에 저랑 같이 연구실에서 연구 지금 같이 하고 있습니다. 그래서 이 친구들이 TA의 역할을 하려고 생각하고 있습니다. 그래서 TA 역할을 하려고 생각하고 있어서 일주일에 한 번씩 이 강의를 할 거고 제일 중요한 강의자를 소개하거든요. 제가 작년에는 제가 강의를 했어요. 제가 강의를 했는데 올해는 저희 연구실에 저보다 더 전문가이고 저보다 더 파이썬을 잘 알고 저보다 더 잘 가르칠 수 있는 연구원이 있습니다. TN 연구원, TN 연구원입니다. TN 연구원은 저희 학교 그 컴퓨터공학과에서 석사로 컴퓨터공학을 전공했고 지금 그 연구원에서 저희 연구실에서 3년 정도 저희 연구실에서 같이 연구를 연구원입니다. 그래서 강의는 TN 연구원이 해줄 겁니다. 영어로 괜찮죠? 영어 강의도 괜찮죠? 네, 그래서 영어로 강의할 거고 일주일에 한 번씩 그 수요일 이 시간에 만나서 강의하는 거 외에 원하는 학생에 한해서 그 강의가 나갈 거고 매주 강의하고 그랬는데 숙제가 나갈 겁니다. 그리고 여러분들 역할은 집에 가서 숙제를 하는 거가 역할인데 첫 주 숙제는 조금 쉬울 수도 있어요. 근데 두 번째 주부터 혹은 첫 주부터 도움이 필요할 수도 있습니다. 도움이 필요할 거예요. 그래서 TA 학생들과 조를 나눠서 아마도 수요일 날 숙제가 나가니까 주말까지 여러분들이 들어오십시오. 네. 하겠습니다. 네. 김덕화 선생님, 네. TA 세션을 하는 게 어떤가 생각합니다. TA 세션이니까 숙제가 나가면 그 숙제를 같이 풀어주고 조를 나눠가지고 학생들이 나와서 같이 숙제를 같이 스터디 모시고 같이 했어요. 그런데 TA 학생들하고 같이 숙제하는데 몰랐던 걸 같이 풀고 그런 세션을 만들까 해요. 그래서 이거는 원하는 학생들에 한해서 하겠습니다. 그거는 원하는지 안 하는지 이따가 끝나기 전에 제가 조사를 하고 넘어갈게요. 여기까지 하고 넘어갑시다. 마지막에 제가 끝나고 나서 시간 조정에 대해서 조금 얘기할게요. 그거는 끝나고 얘기하겠습니다.
Hello everyone. So welcome to our bootcamp in Python programming. So in this course, we're gonna cover some kind of contents. The first thing we have 6 lectures. So we have totally 6 lectures, and next we have 2 program sections. So totally we have 8 contains 8 lectures. The next is the bootcamp covers 7 major topics. So you're gonna know it soon. Analyst. And the most important thing of this bootcamp is you're gonna undergo a lot of homework and practice. So minimum we have 30 homeworks And my advice for you that you will get shocked and get stuck with the homework, I promise, because the homework is not easy. So if you spend 40 minutes and you cannot get any idea to solve the problem, so my advice for you is do not try alone. You can get help from our tutors here. They know solution, and you should do that. I mean, you shouldn't spend maybe 3 hours for nothing alone, stay at home for something like that. No, it's not a good way to learn programming. Even though for very experienced coder, they sometimes get stuck. And when we start learning coding from the beginning, try to solve a problem by yourself is not a good way. Yeah, you need help, and we have a very great tutor here. They will going to help you. And next, you're gonna take 2 case studies, so cover some practice, and I hope that you can apply to your work soon, because it is based on our experience during we do research at General Hospital. And yeah, all the goals contents is supposed to develop your programming thinking. So think like programmer, I hope. The question is why you need programming thinking? Because of this story, it's you, and you stand here, and this is your goal, and this is computer, and of course the computer cannot understand your work, of course not, because our world is ambiguous. This means not clear. Sometimes it's very difficult to understand. But the computer is naive, so it's straightforward. Just a number, 0 and 1, and that's it. And then your problem, you have your problem, but how you can use computer to solve your problem. So to do that, you need to convert your problem to computational problem, which means the problem can be solved using computer. But your problem using human language, for example, English. But a computer cannot understand English, of course. To let computer do what you want, you need programming language. Yes, suggest Python, so we're going to cover Python here. So to convert your problem to computational problem, you need programming thinking. You need know how you can translate the human language in English to naive, straightforward programming language. And after you can do that, after you have a computational problem, you will know how to solve it. That's easy. Try to use Google, and that's it. You just use programming language to convert your problem to computational ones, and then Google will show you how to solve it. Yeah, that's my advice for you, and that's actually what I do every day in my book using Python. So let me show you example. Here I have a 2 file. Let me show them side by side. So if you look at firstly, apparently they look somewhat different. Yeah, if you see the content, they are different. By first looking, but actually they are similar. So the problem is, if you have 1,000 files, something like this, and you want to compare how much they similar to each other, how we can do. So instead of using your mouse and your hands, I mean computer mouse and your hand, try to compare one by one, you can use Python to get the content of the file into your computer memory, and then find alternatively way to compare them. So you just, after you finish your coding, you just press a button and get a copy and wait until the computer can provide solution for you. So okay, that's it. application of programming. This means automate the daily work. Right, so you can save your time. Good. So next, what we do in the lecture. So totally we have around 2 hours in each lecture, and we have 15 minutes for the reviewed lecture. Because I think you will forget my lecture soon after you get home, I guess. And next we have a 1 hour for the today lecture. I mean the lecture of the day. And next, after we finish a lecture, we have the quiz. I mean, just for review what you understand. And finally, we have the practice section. In this section, you will meet our tutor here, and they will give you some hint to solve the homework when you get home. Yeah. So feel free to ask them questions, or if you get stuck in any homework, you can also ask them in this section. All right. Okay, so today we're gonna cover a lot of topics, and the good news is it's so easy. It's for new beginner. So we're gonna use computer, but we have 2 kinds of computers. The first one is called physics. It's for example a calculator. Why physics? Because it's designed for one purpose. It means calculate something new. You cannot do anything else. Yeah. But the computer, we want to focus on the store program computer. It means the computer you have at home, your laptop, your smartphone. So, and even though smartphone very small, the desktop computer very big one, and the medium one in the laptop, but actually they follow exactly the same architecture. So we call it modern computer architecture. And its name is John von Neumann. It's named after the name of scientist, John von Neumann. So in this architecture, we're gonna have an input and output. You can see it on the screen, and you're gonna have a memory, and then this is CPU. So CPU is something here. You see that? So it's very small one, but very expensive. So this architecture, you should remember one thing. That is, when you get the data or your codes, it never ever go directly from input to the CPU. What is input? For example, your keyboard, your scanner, your camera is your input. But the input have to go through the memory before they can enter the CPU. And then after the CPU process the data and provide the output, they have to go through the memory again before they can enter the output. So the output may be the monitor, the printer. So they are the output, and then just show the output to you. Alright, so that's the theory. But in practice, here you can see that we have the disk, I mean maybe SSD, HDD, and we have a random access memory called RAM here. This one is disk, this one is RAM here. This one is CPU. So RAM memory here, and this one is for storage. So keep in mind that the HDD or SSD is just designed for store data. It's not used for calculation. Alright. So RAM memory is designed for calculation. But inside CPU we have a second memory called cache memory. Why we need cache memory? Because RAM memory very fast. RAM memory very slow compared to CPU very fast, because we don't want the CPU weigh the RAM memory. So because you can assume that your friend and you playing a game, that you you prove something to your friend, but your friend is Superman and they very fast, and you very slow because you're just a normal human. So it means that your friend can catch your toys very fast. So it means when you broke it, they need to wait a lot to get your root. So it means you have to work a lot, but your friend just spend 1 or 2 seconds to finish all the tasks. Yeah. So to avoid the waiting, because CPU is expensive, so they don't want the CPU wait for a long time. So they use cache memory here. So the data come into the cache memory and then go into the CPU. So sometimes you go to the supermarket and you want to buy a computer, and you see that two CPU have the same information, but they have a different price because they have a different cache memory. Even though cache memory is tiny, but that's really the major thing beside the price of a CPU. Sometimes maybe $500, around all shipment one, because the cache memory, is so expensive. And next thing, so in your smartphone, I believe you have a smartphone here now. So your smartphone, you can see that your smartphone do only one thing. It's for calculation. So depend on what kind of application you install in your smartphone, they're going to do a specific function. For example, when you install Google Documents, so it means you can use your smartphone as a document editor. So when you install Neighbor, you can use your smartphone for searching information. So your smartphone just designed for general purpose. They don't design for a specific one. So you install application inside that to do what you want. Do what the application is designed for. So actually, your computer and your laptop in the same way. You have an operating system. It means you have Windows, you have Mac OS, Linux, and you install application inside that, and they gonna work what the application is designed for. All right. So generally the computer just used for calculate the number. They do plus, minus, multiply, and something, for example, logarithm. And then they do store data, and that's it. So they decide what kind of instruction you give them. So they're gonna do what you want. So instruction here is the application. And in this bootcamp, you want to create your own instruction. All right. So inside the CPU here, I will show you here. So this device, it will point to your instruction one by one, and when they point to what instruction, so this instruction will be skewed. If this pointer do not point to your program will be never ever skewed. All right. So it's very important, but you don't need to worry about it. You just know. All right. Just know. I just want you to know about it. Is it? Because nowadays the computer work very stable. All right. All right. Let us. Like I said, computer only do what you tell them, and you tell them by programming language. And programming language, you define the calculation, minus, plus, something like that, comparison, and that's it. So simple. And you store data. But in here, you store data inside memory, RAM memory, not in HDD. All right. So we have two kind of calculation. Like I said, we have a minus, plus, multiply, divide, and we call it built-in calculation. This means they decide inside computer decide to do it by default, and they do it super fast. Yeah. And based on the built-in calculation, you want to define your own program, define what you want to do. Alright. And one more thing. Again, I mentioned again, computer is very stupid. They just do what you want them to do. Alright. If you cannot solve the problem by yourself, it means you don't know what you want the computer to do. They cannot do it. So it's up to you. So my advice is for a new beginner, they usually make a mistake that they focus on the computer at the beginning. So do not follow this mistake. Use your pen and paper. Try to find solution by yourself. First, do it manually by yourself. And when you know how to do it, so at that time, you will know what you need to tell the computer to do. Alright. So in here, as I mentioned in the previous slides, in this bootcamp, we're gonna create instructions for computer. Alright. So how we can create instructions? To create instructions, we gonna need 3 ingredients. The first one is problem solving skill. Yeah, of course, you need to know how to solve a problem. And then you need the knowledge of concepts. It means your knowledge about a specific problem. And then after you can solve the problem, then you will translate your solution to programming skill. You translate your solution to programming language by using programming skill. Alright. So before you can solve the problem, do not think about programming. Okay? Think about problem solving. So for example, I think everyone in this room know about this one. You have any idea about this one? It's the DNA. Yeah. This problem is a DNA comparison. How you know a person A and a person B have a relationship with each other or not. They may have a parent or children, or maybe they have the grandparent or grandchildren. So we do it by DNA comparison. And in here, nowadays we use computer to do the comparison. Yeah, of course. And you know the programmer created DNA comparison program. Actually, they have come from biology. They are master DNA knowledge. You know what kind of DNA, how DNA interact to each other, and then they solve it by themselves. But abstraction, they find a general way to compare DNA, and then they translate that into programming. Alright. So the DNA is the knowledge of concepts, and they have problem solving, then translate to computer program using programming skill. So the programmer never ever create a DNA comparison program if they cannot compare DNA by themselves, manually, by the hands. Alright, so we want to cover some kind of knowledge. That's the difference between normal people and developers. The programmer. So the first thing is normal people thinking. So normal people thinking usually think that way. You think using declarative knowledge. For example, the earth rotates around the sun. It means some kind. You just provide statement, but you don't know how to figure that out. Right? Usually you just remember that. For example, you want to find square root of number e here. So for example, what is the square root of number 4? This is number 2. and square root of number 9 is number 3. You know that because you remember. You don't know how to figure it out manually. Alright? So that's the normal people thinking. So, and this kind of thinking do not tell us how to solve it. Alright? How to find any arbitrary number. So if you don't remember, for example, what is the square root of number 1,000,000? 1,500,000. You don't know because you don't remember, but you don't know how to figure out. So to figure out the solution, we need imperative knowledge. So this kind of thinking help you to find a recipe. I mean a specific way to figure out the square root of number. For example, here you want to find the square root of 25. So the first step, try to get any number you want. For example, I guess the square root of 25 is number 3. I guess. Then in the second step, I calculate the square of number 3. We have number 9. But number 9 is not close enough to 25. So I move to the step 3. And then I try to find a new guess. A new guess is follow this equation here. We have a number 3 here. We plus number 3 divided number 3. Number 25 divided number 3. And then I get average. So I get a new guess here. Number 5.67. You see that? So I repeat again. I calculate the square of the new guess and I got a new number here. But unfortunately, it's not low enough to 25 again. So I repeat this process again. I try to find a new guess by on a similar formula here. See that this one and this one are similar. And I guess the new guess here. You see that the new guess very close to 25. I try to calculate square the new guess and I got 25.4. It's very close to the exact result. I mean, very close to the exact result. See that? And if you will repeat this process so many times, you will get exactly the exact number in number 5. Yeah. So by magical. So move on to another example. But in here now we start with number 16. So we repeat the previous process. So you see that I prepare the data for you here. So you see that if you repeat 3 times, so you approximately get the final result around number 4 here. So number 4 is the square root of 16. Alright, so the imperative knowledge different from declarative knowledge. Declarative, you just mean declare something. But in here, you try to find a way how to solve a problem. See that? So from now, every time you try to solve a computation problem, I mean the programming program, focus on this thinking and avoid the previous one. Alright. So let's move to another example. Here we have rhyme number. So I hope that you familiar with this one. So in here, how we can know a number is right or not. For example, number 4 is not a prime number, but number 3. Number 3 is number 2. Number 2. Number 7. Number 11. Alright. So in here, you see that prime number is not, only divisible by number 1 and itself. So you can think in opposite way. It means that in interval between number 2 and itself minus 1, they do not divisible any number inside this interval. So in here, we start with a guess equal to 2 here because number 2 is the minimal prime number, right? So if g equal to s minus 1, we stop. We don't do anything else. But in here, if they do not equal to s minus 1, here we continue to the step 3. Alright? So if we get a modular here, so I hope that you know this one. For example, if you number 5, modular number 2, so you get a result number 1. But
나머지.
number 4.
나머지죠, 나머지. 나누기 한 다음에 나머지 얘기하는 겁니다, 나머지. 그죠? 나머지 맞죠? 네. 네.
Yeah. So you will stop if you get any g number can divisible by number h. Yeah. So if you go through all the possible case and you don't find any g can divisible by h, so it means h is a prime number. So it's so easy. You know how to do it. Alright. So the question is what is recipe? So you can see that the recipe contains a sequence of simple steps, one by one. Very simple. That computer can understand and do it. Alright, but we have a sequence here. Sequence, it means that you cannot change the order. For example, we have a number 1, 2, 3, and 4. So you cannot do the number 2 before number 3. No. You have to follow exactly the order here. 1, 2, 3, 4. Do not 3, 2, 1. Okay. So that's the meaning of the sequence. And next, you need to do, you need to have a self-flow control. So what's e-flow control? You will know later in next lecture. Alright, don't worry. And finally, so the most important thing that you need to know is every program need to stop. I mean, they have to stop in some time. Your program can be skilled 3 days, 14 years, 20 years, but they need to be stopped. So we don't have any program that run forever. So it's not a program, alright? A computer program always have to stop. Okay. So that's enough for the chapter 1. So let's focus on language. Okay, because we learn programming language, so we need to know what's in language. So we have a summary language. Alright, we have English, Korean, Spanish. Alright. So the language we construct is created by using words, and programming language created by using number, strings, and operators. For example, plus, minus, divide, multiply. Alright. So, and language we have a syntax. Similarly, for example, here we have English, we have a cat, dog, boy. This one is wrong in syntax, in terms of syntax. But over here, cat, ox, boy. So it's correct one. We have a subtract. Here we have a verb and we have a track here. Alright. So it's a good one. And similarly, inside programming language, we have a similar tone. Also, we have a syntax here. So we have here operand. I need a number or a string. Here we have a number here and a number here. And between two numbers here, we have an operator, multiply. So this one is correct, syntactically valid. But this one is wrong because you have operands in string and number, but you don't have operators in the middle. So it's wrong. So you need to get the syntax 100% correct. Alright. So if your syntax is not correct, the computer will stop them immediately. They do not allow them to execute your program. Alright. So next, talk about the semantic. So the first here we have the static semantic. So in here I show you example. So But this one in the reverse one, we have syntactically valid and also valid in the static semantic. But in here, it's wrong. It's syntactically valid, but the static semantic error because Python do not support the plus operation between the number and a string. Alright, but the static semantic is based on the programming language. So, for example, in another language, for example, C, they may support this operator, string and a number. Alright, but in Python here, it's 100% wrong. Alright, and next thing we have a semantic. In English, for example, here we have blind planes can be dangerous. So we have two meanings. The first thing you use the planes for traveling may be dangerous.